On July 12, 2022, a phone ring echoed in the office of NASA Administrator Bill Nelson. On the other end of the line was the lead astrophysicist of the James Webb project. The scientist's voice was trembling. He was not reporting success. He was not congratulating on the launch. He asked one single question, which sends shivers down the spine. What have we done? A few hours earlier, when the first data packets from the telescope, located 1.5 million kilometers from Earth, were decrypted and turned into images, silence fell over the mission control room. It was not a silence of triumph. It was a silence of horror. People looked at the monitors and saw things that should not be there. According to all our physics textbooks, according to Einstein's theory, according to the standard model of cosmology, these objects had no right to exist. But they were there, bright, massive, formed. They were looking at us from an era when, according to our calculations, absolute impenetrable darkness should have reigned in the universe. On that day, humanity didn't just get beautiful wallpapers for their desktops. On that day, we broke the universe. We sent a time machine into the past to see the birth of the first light, but we saw that the light had always been there. The data coming from the James Webb telescope right now is forcing Nobel laureates to rewrite their dissertations. We are facing a paradox that could mean one of two things. Either we know nothing about the age of our world, and it is twice as old, or, what is even scarier, the laws of physics themselves, which we considered unshakable, change over time. Today we will break down this cosmic detective story. We will find out exactly what the telescope saw at the edge of time. Why do scientists call these objects the destroyers of the universe? We will learn why the Big Bang might never have happened in the way we were told in school. And most importantly, we will look into the abyss of the question. If our model of the world is wrong, then where do we actually live? In a cyclical universe that dies and is reborn forever? Or in a giant simulation that simply didn't have time to load the textures of deep space? Get ready. What you are about to hear in the next 40 minutes may forever change the way you look at the night sky. To understand the scale of the catastrophe modern science is facing, we need to rewind time, not by a year or two, but by 13,800 billion years. This figure, 13 8/10 billion years, was until recently considered the holy grail of cosmology. This is the age of our universe, the reference point. The moment when, from an infinitely dense and hot point, a singularity, everything was born: space, time, matter, and energy. We call this the Big Bang. But don't think of it as a dynamite explosion. It was the expansion of space itself. Imagine a balloon being inflated. Points on its surface move away from each other, not because they are crawling, but because there is more rubber between them. This is how our universe began to grow. For the first few 100,000 years, the universe was like a thick, red-hot soup of elementary particles. It was opaque. Light could not break through this fog. But then, 380,000 years after the beginning, a miracle happened. The universe cooled down enough for the first hydrogen atoms to form, the fog cleared, and light broke free. We still see this first light today. This is the cosmic microwave background, that very baby photo of the universe for which more than one Nobel Prize was awarded. And then, according to our theory, the Dark Ages began. This is a very important term. Remember it. The Dark Ages. This is an era lasting hundreds of millions of years when there was nothing in space but cold hydrogen and helium. Not a single star, not a single galaxy. Absolute, dead, black silence. Gravity required a colossal amount of time to gather these light clouds of gas into piles, compress them, and ignite the first stars. Scientists built models on supercomputers. They calculated every molecule, and all models agreed on one thing. The first, timid small galaxies should have appeared no earlier than 400 or 500 million years after the Big Bang. And they should have been tiny, irregular in shape, dim blobs that are just starting to gather matter. These were galaxy babies. To grow into giants like our Milky Way, with its beautiful spiral arms and billions of stars, they required billions of years of evolution, mergers, and absorptions. That is exactly what we thought. That is exactly what was written in all the textbooks. We were sure of this scenario. We had the Hubble telescope, which saw space up to a certain limit, and everything it saw fit into this theory. Hubble saw teenagers, galaxies a couple of billion years old, and they were indeed smaller and more chaotic than modern ones. It seemed the puzzle had come together. The story of our origin was understandable and logical, from chaos to order, from simple to complex, from darkness to light. But for astronomers, this was not enough. One question gave them no peace. What was there at the very beginning? How exactly did the first star ignite? To see this, an instrument of a completely new level was needed, a time machine capable of looking through dust and gas, through space itself, stretched by the expansion of the universe. An infrared eye was needed. Why infrared? Here we have to recall the Doppler effect. You have all heard how the sound of an ambulance siren changes when it rushes past you. When the car is coming towards you, the sound is high. When it goes away, the sound becomes low, bass-like. The same thing happens with light. Since the universe is expanding, the most distant objects run away from us at incredible speeds. The light waves they emit stretch out. They turn from visible light into infrared. The farther the object, the redder it is for us. Hubble was an optical telescope. It saw what our eyes see. It could not look into the farthest corners because the light from there had already gone into the infrared range and become invisible to Hubble. We were blind to our own birth. And then humanity decided to build James Webb. This is the most complex, most expensive, and riskiest scientific project in history. Imagine a mirror covered in pure gold, the size of a tennis court. It needs to be folded into origami, stuffed into a rocket, sent to Lagrange, point 2, 1.5 million kilometers from Earth, where no repairman can reach it. And there, in absolute cold, unfold with an accuracy of a nanometer. 25 years of development, $10 billion, thousands of engineers, one mistake, and everything will turn into the most expensive space debris in history. On December 25, 2021, the Ariane 5 rocket lifted off from the launch pad in French Guiana. The entire scientific world held its breath. For the next 6 months, the telescope flew to its target, deploying sun shields the size of a house. Every motor, every hinge had to work perfectly, and they worked. When the telescope cooled down to operating temperatures, almost to absolute zero, and opened its golden eyes, scientists expected to see emptiness, or, at best, those very dim, small, red dots, embryos of the first galaxies. They were preparing to confirm the standard model. They were preparing to check the box. Yes, we were right. Here they are, cosmic babies. But when the first spectral data arrived, it wasn't dim dots that bloomed on the monitor screens. There were searchlights, bright, powerful, huge. It was like walking into a kindergarten and seeing not 3-year-old children playing with blocks, but adult gray-haired men in business suits discussing the stock market. The galaxies that Webb saw in an era when the universe was only 300 million years old were just as massive and complex as our Milky Way is today. This is impossible. It contradicts physics. Gravity works slowly. Matter could not gather into such structures so quickly. There simply wouldn't be enough time for this. If the universe is 13 8/10 billion years old, then these galaxies could not exist. But they exist. And this means that the foundation on which all our cosmology stands has cracked. Let's dive deeper into what exactly James Webb found and why astronomers started using the word panic in their scientific papers. We are talking about galaxies with incredibly high redshift. Scientists denote redshift with the letter Z. The higher the Z number, the farther and older the object. Hubble could see objects with a Z of about 10 or 11. That was its limit. Webb easily stepped over the horizon of 12, 13, and even 14. One of these intruder galaxies was named JADESGSZ140. It sounds like a set of letters, but for astrophysicists, this name sounds like a verdict. The light from this galaxy flew to us for 13.5 billion years. This means we see it as it was just 290 million years after the Big Bang. 290 million years? By cosmic standards, this is an instant. This is the time of one breath. At this time, the universe should have still been warm and empty. But when scientists calculated the mass of stars in this galaxy, they were speechless. It turned out that this galaxy contains a mass equal to billions of suns. Hundreds of millions of stars were already shining in it. Moreover, spectral analysis showed the presence of oxygen, carbon, and dust. Why is this important? Because after the Big Bang, there was only hydrogen and helium in the universe. Heavy elements, such as carbon and oxygen, are born only in the cores of stars. Stars must live their lives, burn fuel, and explode as supernovae to scatter these elements through space. This cycle takes millions, sometimes billions of years. The presence of a large amount of dust and heavy elements in a galaxy that is only 300 million years old is a paradox. It's like finding a modern smartphone with a full charge in the tomb of an ancient pharaoh. Where is it from? Where did generations of stars come from that managed to be born, die, and pollute space with dust if there physically wasn't time for this? At first, of course, scientists thought about a calibration error. Maybe the telescope is lying. Maybe we are interpreting the redshift incorrectly. In science, it is customary to doubt. A group of researchers led by Alison Kirkpatrick, whom the press dubbed the astronomer who broke the universe, double-checked the data again and again. They tried to find a mistake. They prayed to find a mistake, because the alternative was too frightening. But there was no mistake. Spectroscopy, the most reliable method in astronomy, confirmed the distance and composition. Then a second hypothesis arose. An attempt to save the standard model, scientists suggested. Maybe the first stars were different? We know modern stars, population 1. There are old stars, population 2. Theoretically, there should be the very first stars. Population 3. These are hypothetical monsters consisting only of hydrogen and helium. They could be hundreds of times more massive than the Sun, live very brightly, and die very quickly in just a couple of millions of years. If early galaxies consisted of such monster stars, they could produce heavy elements faster. It would be a beautiful explanation. But even if we assume the existence of such stars, the math still doesn't add up. Even if stars were born and died at a frantic speed, gravity still needs time to gather gas into piles. Gas does not fall into the center of a galaxy instantly. It heats up, creating pressure that pushes away new matter. This is a process of self-regulation. Star formation is a slow process. The galaxies found by Webb turn gas into stars at a speed that is theoretically impossible. They seem to violate the Eddington limit, the luminosity limit at which the pressure of the star's radiation tears it apart. These early galaxies were too efficient, too perfect. They didn't behave like chaotic embryos, they behaved like fine-tuned mechanisms. And here we come to the so-called impossible early galaxy problem. Imagine you come to the maternity ward of a hospital. You expect to see babies weighing 3 or 4 kilograms there. But instead, in every second cradle lies an 80-kilogram teenager. You ask the doctor, how is this possible? And the doctor answers, well, maybe they ate very fast. It sounds stupid, but this is exactly the situation cosmologists found themselves in. Mike Boylan Colchin, a theorist from the University of Texas, performed calculations and stated, if these data are correct, We are in uncharted territory. Either we do not understand how galaxies form, or we do not understand cosmology itself. And here begins a real detective story. To explain the existence of these giants, we need to introduce something new into the equation, something that accelerates growth, something dark and heavy. And this brings us to one of the most sinister mysteries of space, to primordial black holes. We are used to thinking that black holes form when a massive star dies, the star collapses, and a hole appears. But what if black holes appeared before stars? What if in the first seconds after the Big Bang, when the energy density was prohibitive, some areas of space collapsed into themselves, spawning millions of black holes even before the first hydrogen atom ignited? These primordial black holes could become the very seeds around which matter instantly began to gather. They could work like giant vacuum cleaners, sucking in gas and accelerating the formation of galaxies thousands of times over. This would explain why early galaxies are so heavy and bright. In their centers sit not just black holes but ancient monsters born in the chaos of the Big Bang. James Webb finds more and more evidence of this. It sees quasars, active galactic nuclei, which shine with the brightness of trillions of suns at a time when the universe was still an infant. The black holes in these quasars have a mass of 1 billion solar masses. How could a black hole gain 1 billion masses in 300 million years? It has a gluttony limit. It cannot eat faster than a certain speed. To grow so big, it had to either eat continuously from the moment of the world's creation, or it was already born big. This is a frightening thought. It means that our universe was stuffed with black holes from the very beginning, like a muffin with raisins, and that we, perhaps, owe our existence to these destroyers. Without them, matter would remain evenly smeared across space, and stars would never ignite. But even the theory of primordial black holes does not solve all problems, because there is another detail that breaks the logic of physics even more. This is the expansion problem, a problem that has been called the Hubble tension, and data from Webb not only didn't solve it, they made it unbearable. We know that the universe is expanding, but at what speed? We have 2 ways to measure this. The first way, look at the early universe, at the cosmic microwave background, and predict the expansion rate based on our models. This gives us the number 67 kilometers per second per megaparsec. The second way, look at modern stars and galaxies and measure their scattering directly. This gives the number 73 or 74, 67 and 74. The difference seems small, but in physics, this is an abyss. This is a catastrophe. It means that either our measurements are wrong or our understanding of the universe is incorrect. James Webb, thanks to its incredible accuracy, rechecked measurements using Cepheid variable stars. The hope was that Hubble was wrong and Webb would correct the figure, bringing it down to 67. But Webb didn't fix it. It confirmed Hubble's data with killing precision. The gap is real. The early universe tells us one thing, and the modern one another. The universe is expanding faster than it should. Some unknown force is pushing it apart. We call it dark energy, but that's just a fancy name for our ignorance. We don't know what it is. And now, putting together impossible early galaxies and the expansion problem, some scientists are beginning to whisper what was previously considered heresy. What if the Big Bang wasn't the only beginning? What if our model of the age of the universe at 13 8/10 billion years is just an illusion? In the year 2023, Professor Rajendra Gupta from the University of Ottawa published a paper that blew up the scientific community. He proposed combining the old, rejected, tired light theory with new data. According to his calculations, if we assume that the fundamental constants of physics change over time, then the age of our universe could be not 13, but 26 7/10 billion years. 26 billion years, twice as old. If this is true, then the problem of impossible galaxies disappears instantly. They had enough time to grow. They had an extra 13 billion years for evolution. But the price of this solution is colossal. We will have to throw almost everything we knew about cosmology into the trash can. We will have to admit that we have been living in a delusion for the last 100 years. But are we ready for this? And what if the truth is even stranger? What if behind the impossibility of these galaxies lies not just an error in age, but an error in the very nature of reality? Let's stop for a second and exhale. 26 billion years. The figure sounds abstract, but if you think about it, it changes everything. If Gupta's theory is correct, then we lose the ground under our feet, because it implies that the fundamental constants of nature, the speed of light, the charge of an electron, the gravitational constant, are not constant. They change. They drift in time. Imagine you are building a house, but the length of your meter changes every day. Today, a meter is 100 centimeters, tomorrow, 90, and the day after tomorrow, 110. Will you be able to build a house that doesn't fall apart? Hardly. But the universe could. And this suggests the so-called fine-tuning. If constants change, then why is life even possible? Why didn't atoms fall apart? Why didn't stars explode or go out billions of years ago? It's like someone is constantly tweaking the radio tuner knobs so the wave doesn't go into noise. Who is this tuner? Or what is this law that we don't see? But let's go back to what Webb sees. The problem is not just with individual galaxies. The problem is with the structure of the universe itself. We know that the universe is not homogeneous. Galaxies are not scattered chaotically like peas on the floor. They are gathered into a giant web, the cosmic web. This is the largest structure in the world. Galaxies line up in long threads, filaments, hundreds of millions of light years long. At the intersections of these threads are giant clusters of galaxies, nodes, and between the threads, huge voids where there is almost nothing. To weave this web, gravity requires epochs. This is a slow, painstaking process. First, small halos of dark matter form, then they merge, then gas flows there, then stars ignite, then galaxies line up. According to computer simulations, in the early universe, in those very first hundreds of millions of years, there should be no web. The universe should look like light ripples on water, not a complex network of highways. But James Webb looks into the past and sees walls. It sees already formed threads. It sees chains of 10, 20 galaxies that had already lined up when the universe wasn't even 1 billion years old. It's like seeing a skyscraper built 5 minutes after laying the foundation. In the year 2023, astronomers reported the discovery of the cosmic vine, a giant structure of 20 galaxies in the early universe. It is too big, it is too orderly. If the standard model is correct, it would have taken billions of years to create such a structure. But it is already there. It exists in the era of infancy. This brings to mind the Hercules Corona Borealis Great Wall. This is the largest known structure in the universe, 10 billion light years in size. It is so huge that light needs 10 billion years to fly along it. The existence of such objects calls into question the cosmological principle itself. The idea that the universe is homogeneous and the same in all directions on large scales. Webb hints to us that heterogeneity was embedded from the very beginning. And here a theory enters the stage that sounds like a horror movie script, but which was supported by one of the greatest minds of our time, Sir Roger Penrose, a Nobel laureate. The theory is called conformal cyclic cosmology. What if the Big Bang wasn't the beginning? What if it was just a moment of transition, a moment of bounce? Penrose claims that our universe is just one of an endless series of aeons. There was a past universe. It was born, lived its life, expanded. All stars in it went out, all black holes evaporated, and it turned into cold, infinitely stretched nothingness. And at this moment, mathematically, the infinitely large becomes identical to the infinitely small. A new Big Bang occurs. A new universe is born. Ours. Sounds beautiful. But what does James Webb have to do with it? The fact is that the past universe could have left scars. Penrose calls them Hawking points. Imagine that giant supermassive black holes existed in the past universe. When they collided, they generated monstrous gravitational waves. These waves spread in circles like ripples from a stone thrown into a pond. When the past universe died and was reborn into ours, these circles didn't go anywhere. They imprinted on the fabric of the new reality. They should be visible in the cosmic microwave background and in the distribution of early galaxies as ring structures. Before Webb's launch, this was considered a fringe theory. But those very impossible early galaxies that the telescope finds, their strange crowding, their monstrous mass, all this can be explained by the fact that they formed not from scratch. They formed on the ashes of the past universe, on the gravitational ghosts of a dead world. If Penrose is right, then we live in a graveyard. The matter your bodies are made of was already part of stars in the past Kalpa, and will be part of stars in the next. This is eternal return, an endless cycle of births and deaths from which there is no escape. We are locked in a time loop of a universal scale. But there is an even more frightening explanation for what Webb sees, an explanation that does not require past universes, but requires a rethink of what gravity is. We say, galaxies could not have gathered so quickly because gravity takes time. But we calculate this based on Einstein's theory and the presence of dark matter. Dark matter is our crutch. We don't see it. We can't catch it in a lab. But we believe it exists because without it, galaxies would fly apart. We add it to the equations to make everything fit. 85% of the mass of the universe is an invisible ghost we invented. But what if there is no dark matter? What if we are wrong about the laws of Newton and Einstein? There is a theory called MOND, Modified Newtonian Dynamics. It states that there is no hidden mass. It's just that gravity works differently at very large distances and at very small accelerations. It becomes stronger than Newton predicted. If we apply MOND to the early universe, then the James Webb puzzle comes together instantly. With enhanced gravity, gas clouds collapse into stars and galaxies much faster. They don't need billions of years. A couple of 100 million is enough for them. Then impossible galaxies become possible. But the price of this admission is terrible. If MOND is correct, then Einstein was wrong. General relativity, the pinnacle of human thought, is wrong or incomplete. All our physics of the 20th century, all our ideas about black holes, about the expansion of the universe, about the Big Bang, all this is built on sand. James Webb is right now, at this very minute, conducting tests that could kill dark matter. It looks at how the outskirts of these ancient galaxies rotate. If it sees certain patterns, dark matter will go to the trash heap of history, just like the ether once did. We will find ourselves in a world where we do not understand the main law governing the movement of stars. We will become children again who do not know the rules of the game. But let's go even deeper, into the very abyss of madness. Look at Webb's deep field images again. Thousands of galaxies in a tiny patch of sky. They are distorted. They are stretched into arcs. This is gravitational lensing. Space works like a lens, bending light. But what if space itself is not what it seems? Among theoretical physicists, the holographic principle is gaining popularity. The idea that our three-dimensional universe is just a projection, a hologram recorded on a two-dimensional surface. Imagine a soda can. All information about the drink, ingredients, calories, brand is recorded on the label, on the surface of the can. But the drink inside is three-dimensional. According to the holographic principle, all information about our universe is recorded on its boundary, on the event horizon. And we, our volume, our stars and galaxies, are just a projection of this information inward. If this is so, then the anomalies Webb sees are dead pixels. These are coding errors. When we look too far into the past, we look at the edge of the hard drive. and their information may be compressed, distorted, or not yet unpacked. Those galaxies that seem impossible to us are artifacts of projection. In the year 2022, a paper was published suggesting that the universe might be a neural network, that the very structure of the cosmic web, these threads and nodes, suspiciously resembles the structure of the human brain or the structure of the internet. It learns, it evolves. Early galaxies appeared so quickly because the network optimized the structure creation process. It learned to create stars faster than random processes allow. Who is the programmer? Or is it a self-learning system that emerged from chaos? The question remains open. And finally, the most exotic theory that connects James Webb and black holes. There is a hypothesis of cosmological natural selection. It states that our universe is located inside a black hole. A black hole in another, parent universe consumed matter. This matter fell into a singularity and, perhaps, blew out from the other side, generating the Big Bang and our universe. Every black hole in our world is the seed of a new universe. Why are physical constants exactly like this? Why is the speed of light 300,000 kilometers per second? Because these parameters were inherited from the parent, but with a slight mutation. Evolution of universes. Those universes survive that create the most black holes, that is, capable of reproduction. James Webb sees that early galaxies are literally teeming with black holes. There are more of them there than there should be. They are too massive. This fits perfectly into the theory. Our universe is a machine for producing black holes. It is sharpened for this. And these ancient monsters that we see at the edge of time are the umbilical cord connecting us to the place where we came from. We live inside the event horizon of someone else's monster. And when we look at the edge of our universe, we see the walls of our dungeon. We started with the fact that James Webb broke the universe. And this is not clickbait. In a couple of years of operation, this telescope has destroyed the confidence we have been accumulating for decades. The standard model is bursting at the seams. The age of the universe is in question, maybe 13 and 8, or maybe 26 and 7 billion years. Dark matter may turn out to be an illusion. The Big Bang might not be the beginning, but just another cycle in an endless series of rebirths. We are on the verge of a paradigm shift equal to the one that happened when Copernicus said that the Earth revolves around the Sun. Then, we were also scared and uncomfortable. We lost the status of the center of the universe. Now we are losing the status of an understandable world. We understand that we understand nothing. Those bright spots in Webb's images are not just stars. They are warning signs, road closed, reality renovation in progress. But there is one thing that scares more than errors in equations. If the universe is indeed cyclical, as Penrose claims, or if we live in a simulation, then what happens to us when the cycle ends, or when someone pulls the plug? Webb's data hints that the universe may be unstable, that the vacuum we live in may be a false vacuum. This is a concept that makes physicists lose sleep. Imagine you are standing at the bottom of a valley. You feel stable. To move you, energy is needed. But what if this valley is not at sea level, but high in the mountains, on the edge of a volcano? You think you are down, safe, but in fact, there is an abyss beneath you. The Higgs field, which gives mass to all particles, may be in a metastable state, like a ball on the edge of a hole. Just a small push, and the ball will roll further into the true deeper hole. If this happens, if at some point in the universe the vacuum breaks through to a lower energy level, it will generate a sphere of decay, a bubble of true vacuum. The walls of this bubble will expand at the speed of light. Inside the bubble, the laws of physics will be different. Maybe there will be no atoms there. Maybe gravity there will repel, not attract. This bubble will burn the old universe, rewriting its code on the fly. We won't see it coming because it travels at the speed of light. We will just disappear. In an instant, everything we knew, all history, all stars, will simply collapse into a new reality. It could happen in 100 billion years, or it could happen tomorrow. Right now, while you are drinking tea, there is no way to predict this or protect against it. This is quantum roulette. And there is a certain grim beauty in this. We live on a powder keg that could become the fireworks of a new world's birth. Perhaps this is exactly what happened to those ancient galaxies. Perhaps we see not their birth, but their agony in the previous cycle. But let's go back to that specific galaxy where it all began. Jades. We talked about it being too bright and too heavy, but there is another detail that scientists talk about reluctantly: its shape. Usually early galaxies are chaos, shapeless lumps, but this galaxy has a disk structure. It rotates. Orderly rotation takes time. A disk forms when gas calms down and cools. It takes billions of years. The fact that we see a calm, rotating disk just 300 million years after the beginning of time contradicts everything we know about hydrodynamics. This forces us to consider another completely crazy hypothesis: the dark star hypothesis. We are used to stars shining due to thermonuclear fusion. Hydrogen turns into helium. But in the very early universe, when the density of dark matter was colossal, objects could exist that ran on different fuel: dark stars. These are not stars in the usual sense. These are giant clouds of hydrogen, the size of our solar system, which do not compress to the end, because annihilation of dark matter particles occurs inside them. Dark matter heats itself. These objects would be cold but incredibly bright in the infrared. 1,000,000 suns in one object. If James Webb sees not galaxies but precisely such single dark stars, then the mass mystery is solved. We don't need many stars. We need just one, but a monstrous one. But if dark stars existed, where did they go? They must have turned into supermassive black holes. And this brings us back to the idea that the foundation of our world is built by monsters. Every new image from Webb is a nail in the coffin of the Standard Model. Recently, the telescope found another anomaly: planets the size of Jupiter flying in the Orion Nebula, not around stars, but in pairs, on their own, rogue binary planets. They are called jumbos. There are dozens of them. How did they form? The usual theory of planet formation cannot explain this. Planets are born from disks around stars. Flying out of a system as a pair is statistically impossible. This suggests that star formation works differently than we thought, that nature knows how to create objects of any scale directly from the void. And if it can create planets without stars, can it create life without planets? Can life exist in open space, in the gas clouds of the early universe, feeding on the heat of those very dark stars? Webb showed us that complex organic chemistry already existed in the early universe. Molecules that are the building blocks of life, aromatic hydrocarbons. They were there when the universe was only 1.5 billion years old. This means that the ingredients for life are ready immediately. The universe doesn't wait. It wants to be alive. Perhaps we are alone, not in space, but in time. Perhaps civilizations flash and fade constantly, but they are separated by billions of years of silence. Those ancient galaxies we are looking at now could have been home to trillions of beings who lived, loved, fought, and died long before Earth formed. We are looking at their graves. Light is their death mask. And here we approach the Hubble tension problem from another side. If the universe is expanding faster than it should, it means that, in the future, we will stop seeing other galaxies. Space will become empty. We will find ourselves in isolation. But Webb's data hints that perhaps our understanding of expansion is wrong because we live in a special place, in a giant cosmic void, in a void. Imagine that the Milky Way is in the center of a huge bubble where the density of matter is lower than the average in the universe. The gravity of the walls of this bubble pulls galaxies outward, forcing them to fly apart faster. This would create the illusion of accelerated expansion. If this is so, then we don't just live in a random place. We live in the emptiest, most boring province of space. in a galactic backwater. And this is exactly what saved us from the disasters raging in dense clusters and allowed us to grow. We are children of the void. This explains why we don't see aliens. In the center of megacities, life boils and perishes, and we, villagers, sit in silence and wonder where everyone is. But Webb destroys this hope for peace too. It shows that even in the void, processes are taking place that can destroy us. We looked into the abyss of time and saw monsters there. But the scariest thing the James Webb telescope did was not looking back. It was looking sideways. It unfolded its golden mirrors and looked at our neighbors, at planets orbiting other stars. And what it saw there forces us to rethink not only physics, but also biology, and even theology. We have been looking for life for decades. We listened to radio signals. We looked for Dyson spheres. But Webb searches differently. It sniffs. It analyzes light that has passed through the atmosphere of a distant planet and breaks it down into a spectrum. This is the barcode of reality, and in this barcode are recorded the molecules that are flying there. In September 2023, NASA published a report that should have been the main news of the century, but drowned in information noise. Webb looked at the planet K2-18b. It is a world 120 light-years away. It is not Earth. It is a Hycean, a new class of planets we hadn't even guessed about before. A hot ocean covering the entire surface and a dense hydrogen atmosphere. It would seem like hell. But spectral analysis showed the presence of methane and carbon dioxide. This is normal. But there was another signal, weak, uncertain, but it was there, dimethyl sulfide. Remember this word. On Earth, this substance is produced only by living organisms, phytoplankton in the oceans. No volcano, no geological process can create dimethyl sulfide in such quantities. If Webb's data is confirmed, and the probability is 50-50, it will mean we have found life. But this is not the life we dreamed of. It is life in a boiling ocean under pressure of thousands of atmospheres. Life that will never come out onto land because there is no land there. Life that will never see the stars because the atmosphere is too dense. This discovery is a double-edged sword. On the one hand, we are not alone. Hooray. On the other hand, it confirms the darkest guesses of the Fermi paradox. Life is mold. It arises wherever there is water and energy. It is incredibly tenacious. But reason, technologies, radio, this is an error, an anomaly. We can find billions of planets with algae, but not a single one with interlocutors. We will forever look at green oceans of slime, and this slime will be silent. But Webb went further. It looked at the TRAPPIST-1 system, 7 Earth-sized planets. 3 of them are in the habitable zone. This is an ideal target, a colonist's dream. But when Webb checked their atmospheres, it found emptiness. The planets either have no atmosphere at all, or it is so thin that life is impossible there. Their star, a red dwarf, simply blew away the air with radiation bursts. This is a graveyard of hopes. We realized that red dwarfs, the most common stars in the universe, are bad parents. They kill their children. This crosses out 75% of the galaxy from the list of potentially habitable worlds. Our cosmic home has become even smaller and even lonelier. And now, let's return to our solar system. Webb looked at the moons of Jupiter and Saturn, at Europa and Enceladus. We knew there were subsurface oceans there, but Webb saw geysers, fountains of water shooting into space to a height of hundreds of kilometers. And there is organic matter in this water. This means life can be not only on planets, it can hide. It can live in the dark, under a kilometer-thick layer of ice, feeding on the heat of the core. This changes everything. If life hides, then we don't see it, not because it's not there, but because the universe is a dangerous place. Radiation, asteroids, supernova explosions. The surface of a planet is the front line. Living on the surface, like us, is a suicidal strategy. Normal life sits in a bunker. We are idiots who went out onto the roof during an artillery barrage and wonder why no one else is there. We shout into space, and the rest of the galaxy sits under the ice and perhaps listens to us with horror, waiting for us to get hit. Webb is capable of searching not only for biosignatures, traces of life, but also for technosignatures, traces of machines, industrial gases, freons. If a civilization developed just like us, it must have polluted its atmosphere. Freons live for 50,000 years. If they died recently, we will smell their corpse scent. The telescope has already begun scanning nearby star systems for these markers. Imagine a report arrives tomorrow. We found a planet whose atmosphere is full of industrial pollutants, but no oxygen, no water, no methane. This will mean only one thing. They burned their home, they killed the biosphere, suffocated, and died. And their factories might have continued to work automatically for another 1,000 years until they rotted. We will see a monument to stupidity, and this monument will be a mirror for us. Now we are doing the same thing. We are changing the composition of the atmosphere at such a speed that future geologists will name this layer after us. Webb shows us that there are far more scenarios for the end of the world than for survival. But let's digress from planets and return to the very structure of reality. Webb's data on the early universe, on those very impossible galaxies, resurrected another frightening theory: simulation theory. Why did galaxies form so quickly? Why does physics at the edges of the universe work differently than here? Why doesn't the expansion rate match? Programmers know the answer. It's called optimization. When you make an open-world game, you don't draw every leaf on a tree 100 kilometers away from the player. You make a flat picture there. Low poly texture. James Webb is a player who took out binoculars with 1,000-fold magnification and looked at the horizon. And he saw that the textures there are bad. They didn't load. Galaxies look like disks, not complex spheres. Gravity laws are simplified. There is no dark matter because the server is too lazy to calculate it for distant objects. What we call breaking physics may simply be a rendering artifact. We have reached the computational limit of our simulator. We are looking at pixels on the creator's monitor screen. Those very impossible bright objects are just engine bugs that were not designed for someone inside the simulation to be so curious as to build a $10 billion mirror and look at the very beginning of the code. If this is so, then two outcomes await us. Either the developers will release a patch, and tomorrow we will wake up in a world where physics has changed, constants have shifted, and galaxies have rearranged. We won't even notice the memory swap, or they will decide that the experiment has gone out of control, that the bots have become too smart, and they will press the stop button. The great filter in this case is not a nuclear war or a virus. It is the moment when a civilization realizes that it is unreal, and this moment is coming now. But let's assume the world is real, that matter is matter, that we are, after all, made of flesh and bone, not zeros and ones. Then Webb's conclusions sound like a sentence to our pride. We thought we understood the world. We built the standard model. We wrote formulas. We were so sure of ourselves. Webb showed us that we are children who found a watch on the beach and think they understand how time works. 95% of the universe is dark matter and dark energy. We don't know what it is. Now it turns out that we don't understand the remaining 5% of ordinary matter either. We don't know how stars ignite. We don't know how black holes grow. This is a crisis of competence. But it is also the greatest gift, because a science that knows everything is a dead science. Webb returned the mystery to us. It returned to us that very feeling of sublime horror that ancient people experienced looking at a thunderstorm. We are small again. We are stupid again. And it is beautiful, because only a fool who has realized his stupidity can start learning. Right now, while you are listening to this, James Webb is hanging 1.5 million kilometers from Earth back to the Sun, face to the darkness. It works 24 hours a day. Every second it pumps terabytes of data that break someone's careers and give birth to new theories. Perhaps right now, it is taking a spectrum of a planet where there is intelligent life. Perhaps it sees light from lasers of an alien civilization, or perhaps it sees the edge of the universe beyond which begins nothing, or another universe that is rushing at us to collide and destroy everything. There is a dark flow theory. Data shows that a huge part of galaxies, including ours, is flying in one direction at a frantic speed. As if there, beyond the horizon of visibility, is something incredibly heavy. The great attractor is a trifle compared to this. This something is pulling us. We are like water in a bathtub drain. We circle and fall into the unknown. Webb can help us see the edge of this funnel. What is there? A giant black hole the size of 1 trillion galaxies? Or the junction of our universe with a neighbor? We don't know. We are passengers on a train with painted windows, which is gaining speed. Webb is a needle with which we scratch the paint on the glass. We pressed our eye to this hole and saw fire. What conclusion can we draw from all this chaos? The universe was not created for us. It is not friendly. It doesn't care about our ambitions, our wars, and our hopes. It is cold, huge, and full of monsters that can swallow our solar system without even noticing it. But we are here. We exist. Despite entropy, despite chaos, despite probability. We are matter that has gained a voice. We are atoms that have learned to call themselves by name. The fact that we were able to build such an instrument as James Webb is a miracle. We took sand, melted it into mirrors, covered it with gold, launched it on a pillar of fire into the sky, and are now looking into the eyes of God or nature or chaos. Call it what you want. We shouldn't be afraid of what we've learned. Yes, the standard model is broken. Yes, the Big Bang is in question. Yes, we may be alone. But this only makes our life more valuable. If we are alone, we are the keepers of the fire. We are the keepers of meaning. If we go out, the universe will become just a pile of rocks. Our task is not to look for saviors from the sky. They are not there, or they are dead, or they are hiding. Our task is to become the ones we would like to find, to become a great civilization, to survive our technological youth, not to blow ourselves up, not to burn the planet, to become adults. James Webb gave us a map, a scary map. It marks dragons, cliffs, and dead ends. But it is a map, and having a map, you can plot a route. We are on the verge of new physics, a new era of discovery. Perhaps in 10 years, we will understand what gravity really is and build a warp drive. Perhaps we will understand dark energy and get an infinite power source. A crisis is always an opportunity. The old building is destroyed. The foundation is cleared. Now we can build a skyscraper. So, what have we done? We woke up. The phone call to Bill Nelson was not about a disaster. It was an alarm clock. Good morning, humanity. It's time to open your eyes and look at the real world. It is strange. It is broken. It is frightening. But it is ours, and we have no other. Thank you for walking this path through space and time with us. If your brain is boiling from theories now, if you feel like a grain of sand in a hurricane, but at the same time feel a strange greatness, then we have achieved our goal. Like this video, it helps promote science to the masses. Subscribe to the channel because in the next video, we will look where even Webb cannot look. We will talk about what is inside a black hole, a singularity, a portal, a library, or an exit to the universe's computer console. Reality is much thinner than it seems. Don't switch. And look at the stars. They speak to us. We just started learning the language. See you.